Okay, 6th grade. Our objective today is to talk about circles, okay, which in my mind, it should be a pretty easy quiz for you guys. Okay, so that'll be Tuesday, and then we're going to move on to surface area, volume, and all that other fun stuff on Wednesday. So I want to start with the warm-up, okay, and then actually before I ask you guys for answers, who can remind us what the area formula for a parallelogram is? Alyssa? Good, base times height. What about a triangle, Doug? Good, 1/2 base times height or base times height divided by 2. Justin, what about a square? Good, side squared. Annalise, what about a rectangle? Good, length times width. What about a trapezoid? Briar? Good. So you could also think of it as 1/2 times base 1 plus base 2 times height. Either way, whether you like multiplying or dividing it. Mary, do you have a question? Okay. So can someone also explain to me the relationship between a square, rectangle, and a rhombus? Can someone explain the relationship to us? I have a square, rectangle, and a rhombus. And of course, in your own words. Matt, what do you want to say? Good. They're all quadrilaterals. What else can we say? Mary? Good job. Say that again. Good job. Doug, you want to add to that? You just have your hand up just because. Okay. Annalise? Yes. Perfect. And then in regards to the square and the rectangle, they all have 90-degree angles, but a rhombus could, but it doesn't have to always have 90-degree angles. So that's one other thing you guys could say about that. What's something you could tell us about polygons, just in general about polygons, Alyssa? Say that again? Good, no round sides. Emma H. Good, only intersect on the endpoints. Matt? Good, they're closed. Donatus, what else can you say about a polygon? There's different types. Give me a type. Good, hectagon. Annalise, what else? Good, what's the difference? Good, so concave, thanks, Victoria. Do you need the other one? The start of it is underneath that white folder. Just go ahead and grab it. So concave, they're caving in. Convex, they're kind of poking out. You could also put the 2 dots in the middle of the figure anywhere and draw a segment between them. If it goes out of it, it's concave. If it stays within it, it's convex. That's not the most common way to do it, but Mary? Yeah, that's the start of it. Good. Okay, that's pretty much everything we've been going over. Charles? Okay, there you go. Anything above 12, we call an n-gon, so just keep that in mind. If there's 14 sides, it's a 14-gon, 15 sides, a 15-gon, etc. All right, Zach, number 1 on the warm-up. Units, what? Good. Briar, number 2. Good. Adam, number 3. Good job. Number 4, Sean. Good job. Number 5, Annalise. Good. Number 6, Charles. Good job. Number 7, Mary. Perfect. Jeremy, number 8. No. Emma? M? What'd you say? You want to try? Okay. Alyssa? Good. X equals 16, and that one was centimeters. Number 9, Emma H. No, you forgot about the times 2. Matt? Good. All right, so let me pause on that. Anthony, if you're done, just put that on my desk, okay? Or in the done pile. The done pile works. Thank you for doing that. Emma? Number 8, okay. So let me just do this. Okay, number 8 for all of you guys who missed it. Okay, we have 187 equals 1/2 times 17 times x plus 6. So let me just pause there. Do you understand that initial setup? The x could be base 1 or base 2. Okay. You could do it either way. Do you want me to, let me leave it as divided by 2 since you did it that way. Sorry, I'm trying to talk myself through this here. So the divided by 2 here. So there's 2 ways you can do this. Okay, if you're dividing this by 2, yours looks like this, right? Okay. You can either divide this by 2, or you can multiply both sides by 2 first. What do you prefer? Okay, so what's 17 divided by 2? Good. Okay, so you have 8.5 and then x plus 6 in parentheses. To get rid of the 8.5, I recommend dividing both sides by 8.5 instead of distributing, because you'll kind of save yourself some work. Did you do that or did you not? Okay. So if you divide by 8.5, you end up with 22 equals x plus 6, and then just minus the 6 on both sides, so you get 16. So Emma, if you did do it this way and then you distributed, it's still pretty much the same process. You would just have an extra step added on. Sure? Okay. Annalise? Nope. Mm-mm. This is all one term. So no, as long, like the 17's already out of the x plus 6. So if you think back to chapter 2, as long as you divide part of it, you're fine. You don't have to divide all this either. Because this is one term. It's kind of like if you said, okay, 8 over 2 is the same thing as 4 times 2 over 2. No matter what you're doing, look, you could either cancel the 2's here, or you could just do 8 divided by 2 is 4. Either way, you get 4, whether it's broken into 2 things or broken into 1 thing. You don't divide each term by the denominator if you split something into the product of 2 numbers. Never. So it's one of those math things we talked about in chapter 2 that it's just one of those rules you follow. It's one of those properties that if you're dividing something by 2, it's not every single thing if multiplication separates it. No, times. There's no plus. Remember, the formula is multiplication. Divide by 8.5 on both sides. Okay, anyone else on the warm-up? Mary? 9. Okay, let me just set it up the way that you did, if I can move my smart board. Come on. Okay, Mary, tell me your initial setup for number 9. Okay, so you like 0.5. All right, so I recommend taking 0.5 times 21 first. Okay, you divided both sides by 21 first? Okay, you could do that. What did you get? Okay, that's right. Okay, then what did you do? Okay, so do 19 divided by 0.5. You just answered your own question. Do you have your calculator? No, do 19 divided by 0.5. You get 38. You tell me. Why wouldn't you multiply here? You want to get rid of it. If you multiply 1/2 times 1/2, you end up with 1/4, or 0.25. You want to get everything away from x. So the only way you can get rid of it, think back to chapter 2 or 3. These go away. Okay, so you just forgot about your equation solving. You okay? Okay. Briar? Times 2. Yep, that works. There's a lot. That's why I asked how she did it. There's a lot of ways to kind of set this up. Okay, anyone else on the warm-up? All right, let's move on to the homework. Okay, see how that went. I know I'm going to have to talk about the last 2 problems, but let's go over all the answers here first. All right, Doug, we're going to start with you on number 1. Good. 33.48 what? Good. Okay, Justin, number 2. Perfect. Matt, number 3. Good job. Number 4, Emma H. Perfect. Donatus, number 5. Good. Alyssa, number 6. It should be 14.4. Okay, yeah, 14.4. Okay, number 7, Emma M. Kind of centimeters squared. Good. Adam, number 8. Okay, but it shouldn't be anything multiplied by 2. It should always be times 1/2. Yeah. All right, tell me what you have for number 9 then. No, number 9. Tell me what you have for number 9 since you... Okay. Mary, back to number 8. What'd you get? Good. Charles, number 10. Good job. Annalise, number 11. Good. Sean, number 12. Good. And what kind of figure was it? Good. I'm just going to abbreviate because I don't have much room here. Number 13, Briar. Or no, you don't have yours. Zach, 13. Say that again. No, but what kind of figure is it? Nope. I think you plotted your points wrong. Mary? Trapezoid, and what was the area? Okay, good. Okay, Doug, number 14. Nope. Justin, 14. Nope. Matt, number 14. Thank you. I'll come back to you and have you explain that in a couple minutes, okay? Number 15, Mary. No, but you're close. Donatus? Awesome. 524 inches squared. I'll come back to you to explain that maybe in a little bit. All right, so let's hold off on the last 2 for now because I know I'll have Matt and Donatus come up and show us how they drew that. 1 through 13 questions. Adam? 4. Number 4. Okay, number 4 you should have done, I'm going to kind of read through the first part of the formula. 1/2 times, in parentheses, 7.1 plus 9.3 times 7.5. Yeah. 1/2, and then base 1 plus base 2. Did you watch the video from yesterday that you missed? The whole thing? The whole thing? Did you take notes? Yeah, but you were taking your test. So that's probably the problem. No, this was yesterday's lesson. So Adam, you need to watch the lesson, take notes, write the formula down. Okay? So anyways, it's 1/2 times parentheses base 1 plus base 2. Are you done, Danielle? Okay. Base 1 plus base 2 and then times height. So watch the video, Adam. That will be very helpful. Okay? And then come back to me Monday if you still have questions on that. Annalise. So it's hard for me to explain this without putting the picture up. So if you look at the parallelogram here, if you just count over how long this is, You just count it. That's why it's on a coordinate plane. It's 6 units. Your base is 6 units, and the height is 4 units. So you just take 6 times 4. That's why they had you graph it on a coordinate plane. I don't know what that means. You count from here, this side to this side, and you get 6. And then you count from here to here, and you get 4. So here to here is 6, here to here is 4. You want to count the base and the height. You just multiply. That's why it's on an actual graph, so that you're able to count. You just count wherever it's nice and flat for you. It doesn't matter. You can count either where the x-axis is or the one below or above it. It doesn't matter. Thank you, Victoria. That's fine. Annalise, you know what I mean? Okay. Doug? Okay, Annalise, are you okay on 13, on counting the bases? Okay. Anyone else on 1 to 13? Emma H? Okay, what happened with 8? Okay. Okay, so let me just read to you the first part of 8, see if that helps you. Because you should have area equals 1/2 times, in parentheses, 32.5 plus 26, and then times the height, which is 13. So when you add what's inside parentheses, you get 58.5. Okay. I'm going to write it up here for you if you need me to. Okay, so once you have that 58.5 in parentheses, you should take 1/2 times 58.5 times 13. Did you get it? I'm guessing since you didn't show your work, you don't know what the problem is. Okay. It's also easy to type something wrong into the calculator, so just be careful there, but that happens. Okay, Annalise? There's not a slanted base. You can put it on my desk. I'll talk to you about it later. There's not a slanted base. Okay, this is your trapezoid. If you look at it this way, base 1, base 2, height. Bases are flat. So sometimes it's going to be oriented the other way, like rotated around. Okay? Doug, is this a real question this time? Go ahead. Okay, 12 is not a trapezoid. It's a parallelogram. It looks just like this. You plotted your points wrong. Plot your points again. Okay? Alyssa? Okay, so on the parallelogram, if you count over, this is 6 units. So you know the base is 6. If you count here, the height is 4. 6 times 4 is 24. That's okay. And then this one, base 1, base 2, height. Does that help? You sure? Emma? On 10? Oh, I'm sorry. I knew I'd forget that. Thank you. Number 10, Emma H, is 135 equals 1/2, in parentheses, 29 plus 31 times the height. So let me just stop there. Did you do the times 1/2, or do you do the divided by 2? Okay. Are you okay with it set up this way, or do you want me to change? You sure? So then the 135 equals, I always add what's in parentheses first. It makes it easier. And then take 1/2 of 60. And then divide by 30. So you'd still get 4.5. I would recommend showing your work so that if you do miss something in the future, especially on the review that we're going to do Monday, it's easier for you to tell what you did wrong. Okay. Yeah, and I mean, it's completely up to you guys whether you like multiplying by 1/2 or dividing by 2. That's just preference. I just prefer the multiply by 1/2. I just think it's quicker. But you don't have to do what I'm telling you to do. You can do whatever you think is easier. Okay, anyone else on 1 to 13? Annalise? Well, yeah, but we're going to get to that one right now. Okay, Matt, can you come up and show us how you split up your shapes for number 14? Do you need to see mine? Just so you can ignore what I did. Do what you did. And then I'm going to have Donatus show us 15. And yes, there's different ways to do this. I was talking to Mary about that this morning. Here, you don't have to worry about all the triangles and stuff. Yeah, you can draw with your finger. Yep. Okay, so when you're done, just tell us what you did and why you did it. Okay. Good. Yep. Plus 50 is 92. Awesome. And that's how you can leave it up there. Leave it up there. If you don't mind, put the pen down. I'll undo what you just did. Thank you, Matt. Okay. Anyways, I agree with him. I did that the exact same way. Yes, of course, there were other ways to do it, but the way that Matt just explained, anyone have questions on how he got 92? Annalise? Right, right. Yep. Yep. My personal opinion is I think this way is the easiest to split them, but again, you don't have to do it that way. Charles? Okay, did you do it this way instead of this way? Did you split them this way? What did you do? Oh, okay. Just more work, but you can do it that way. Okay. Okay. Well, that's a very interesting way to do it, and that's, I mean, of course, fine with me. Just be careful that you don't miss one. Yeah. Sean? Number 12? We're back to 12? Okay, okay, okay. Yes. Okay. Like you're saying you put 5 here. Oh, yeah, that's not right. This would have to be 5. And that would have to be 7. But again, it's not even necessary to do that because you can just split it how Matt did. It kind of makes it a little bit easier. You okay? Okay, Annalise, go ahead. Trapezoid. That's why you have 2 bases, because it's a trapezoid. Or sorry, I thought you meant 13. Number 12 is a parallelogram. A rectangle does not have slanted sides. It looks like this. This is not a rectangle. Okay, Donatus, can you come up? Let me draw it, and then I want you to show us how you split it. Okay, Donatus, come on up. Show us how you split this. I completely agree. And then what'd you do? Just real quick, what did you do then? Yep. Wait, tell me what the second base of the trapezoid is. Good. Perfect. So can you just write a 20 up there for your second base, and then you're done. That's what I did. Go ahead, Matt. What did you do? Okay. Okay. You forgot about that rectangle. Okay. But yeah, I don't know. I think that's pretty easy. Alyssa? Up and down. Okay. So if you would have, then you're good, right? Okay. Good. I'm glad you redid it. Mary? Okay. Okay. Yeah, that's okay. Then I'm guessing you either calculated something wrong in your formula or one of your bases was wrong. Did you try to do it again yet? Okay. Maybe not right this second, but at some point try it again. Do you understand it the way that Donatus did it, just in case? Okay. Sean? Yep, that's what we're on. Did you split it this way? This way? Okay, I recommend trying this way. It's easier. All you're dealing with is a trapezoid here and a rectangle here. So I would actually redo how you did it because it's much easier this way. Okay, I would always try to go for the easier way, especially when you have complicated figures like this. When we get to surface area and volume, they're going to be even harder, but we're going to have to split them up and figure out something, surface area or volume. Okay, Annalise? Yeah, I highly recommend doing it this way. Just keep it easier for yourself. To me, a rectangle and a trapezoid is much easier than two trapezoids. So, all right, time for circles. Okay, anyone else on homework real quick? Okay, open up your notes to 10-4. I'm guessing it's page 11 in your notes. Okay, is it page 9? Thank you. Page 9. I keep trying to guess. Mine is page 10. Okay, yours is page 9. Time for some circle talk. This lesson is not going to take us very long. Of course, it's pretty easy. So, Donatus, we are going to be using pi today. We're not using what? No, we're using pi. Okay, so circles. Hold on 1 second, guys. Okay, so we're going to find circumference and areas of circles. So let me hold those comments till the end of class because we need to at least talk about circles for 15 minutes. Okay, I am starting with a couple definitions for you guys, okay, and then we're going to get into some formulas. So very, very basic, but again, you'll see this on PSSAs. You need to know that diameter is the distance across the circle, and it goes through the center. I'm sure you guys all know that, right? Diameter is the distance across the circle, and it goes through the center. So I'm going to draw one for you. Of course, it's not going to be perfect, but so what is something that kind of looks like a diameter, but of course it's different? Briar? Say that again? Well, that looks like a circle. Yeah, okay, I see what you're saying. Yeah, so that works. But I'm asking that wrong then. There's another line that can go through a circle that's kind of like a diameter. Adam? Well, no, kind of. The radius is half of it. I'm thinking of something else. Zach? Good, a chord. What's different about a chord? Zach? Yeah, the chord looks just like it. It's still a segment that goes from one end of the circle to the other, but it does not go through the center. So, hey, a tire works, right? But I just wanted to see if you guys remembered what a chord was. Sean? Yes, yes, but a chord is not always a diameter. Yeah. So a center, all points in a plane that are the same distance from a fixed point. Common sense. We could be standing in the center of the room. We could define ourselves as the center because if let's just say this was the center of the room, I would be the same distance from all points in the room, okay, if you were standing in the center. Now, of course, it'd be much easier if it was a circle room, okay? So we're the same exact distance from where I am to every single spot on the end of the circle, okay? So there's always a center of a circle, and it's always going to have a name. You know, circle G, circle B, circle A, whatever. Emma. Yeah. Yeah. You can shorten, change definitions however you want. Okay. The radius. The distance between the center of the circle and any point on the circle. Yep. So if here's the center, whoop, there's our radius. Again, this is just basic stuff that you guys already know. Should know. Okay, area, the space inside a circle. Be kind of cool to have a circle classroom. Be kind of cool. Well, yeah, I was saying, it'd be kind of cool to have a circle classroom. Okay, the space, hold that comment, Adam. The space inside the circle. Let's hold comments, hold comments. You can write down whatever you want. You should write something down. Okay, so let's do some examples. Oh, wait, I forgot one. Sorry, forgot about circumference. Circumference is just like perimeter. It's the distance around the circle. So circumference is just like finding perimeter, of course, different formula. Because a circle is not a polygon because it has curved sides, so you can't just add up all the sides because there's not sides. So we're going to talk about the circumference and area formulas today. That's pretty much the bulk of this lesson. Justin, question? Okay. So again, here's one more time. I took a picture of a circle from your book with all the labels on. I know you know this, but here it is again. Yeah, with the online book, it's easy. There's not a chord on that, Jeremy. We didn't take definition of a chord. I just talked about it. Okay, what is one formula to find circumference of a circle, Briar? Yep, Sean, what's the other one? Good. So 2 formulas for circumference. You pick the one that looks prettier to you, but I would still write them both down. Circumference equals 2 times pi times r, or circumference equals pi times diameter. They're the exact same thing, so you can use either one. I typically will use whichever one's easier, depending on what they give you. If they give you the diameter, I use the formula with the diameter. If they give you radius, I will use the formula with radius. Okay, how do we find area of a circle? How do we find area, Donatus? Good, which you could also write that as, hey, Donatus. Good, pi r squared. So area equals pi r squared. Now, a comment about pi. The calculators have a pi button. So be careful, though. The pi button on your calculator is, of course, much more accurate than just using 3.14. But for this chapter, we're just going to use 3.14 because PSSAs and most standardized tests just tell you, hey, use 3.14 for pi, even though we know it keeps going on much longer than just 3.14. Sean? I'm 99% sure, yes. I'll double check to make sure. Is this a question? Go ahead. Guys, listen. If you were to put what? A big what? It's okay. It's okay. I'm just telling you, typically that's what you use. Okay? Not is this a question? Okay, go ahead, real quick. Yeah. But we're just using 2 pi r. Okay, so let's do a couple problems, starting with, this is really easy. Okay, example 1, we're just doing A here, okay? Briar, what's the diameter? That's why I wrote them up here. Okay, hey, quiet. Diameter is 20, and it's hard to see, but it is kilometers. So if the diameter is 20 kilometers, Mary, what's the radius? Okay, let's do one more just to make sure. Good. Let's go to letter B. If you can't see it, here's mine. There's a line through it, 14 centimeters. Jeremy, what's the diameter? Good. Matt, what's the radius? Good job. Okay, flip over your notes to the next page. Okay, so we have our coin, and it says that the directions tell you to use 3.14 for pi. This is very common, so we're going to use 3.14. It asks us to find the circumference and the area. What circumference formula should we use for letter A? Matt? Okay, just remember, guys, it's not pi times the denominator, right? I'm just kidding, Matt. Pi times diameter, we're given the diameter. So in your calculator, you would type in 3.14 times 1.8. Circumference is distance around the circle. What do we get, Justin? Centimeters, good. And remember, it's just regular units because it's like perimeter. It's the distance. Oh, does it? Thank you. My fault. My fault. Thank you, guys. Here I go again with not following directions. Okay, area. Adam, how do we find area of a circle? Good. Pi r squared. Zach, what's the radius in this problem? 0.9. So on your calculator, take 0.9 squared first, and then hit enter, times 3.14. You could also type in 3.14 times 0.9 squared. There's a lot of ways. Either way, Charles, what's the area? Okay, round to the nearest tenth. Did you use the pi button? Okay. If you use 3.14, what do you get? Justin? 2.5 centimeters squared. That's okay. I won't mark it wrong on a test, but just because here it tells us to use 3.14, just trying to be consistent. Okay, are you guys okay with just one of those examples? Okay, let's go to the Roman numeral 3. Let's go to the steering wheel. Okay, so here it says find the radius and the diameter of each figure. Use 3.14 for pi. Round your answer to the nearest tenth. So what's different about this one? Sean, what's different? Yep. What else is different about what they gave us? Like, what do we have? What's this? Good. So we're given area instead of a radius or diameter, which I'm sure is common sense. So we have 735 equals pi r squared. Okay, we have to find r first. So Alyssa, what do we do next? Yep, so divide both sides by 3.14. Okay. After you divide by 3.14, what do you get? Justin, what did you get? Good. So 234. I'm going to keep it as 0.08 for now, because I'm not going to round to the very end. So equals r squared. Okay, now how do we get rid of the square, Emma H? Emma H, yeah. Good. Square root both sides, kind of like the bonus on your Chapter 7 test. So rounded to the nearest tenth, what is the radius? And you should be hitting second x squared on your calculator. Annalise, what'd you get? Divided by 3.14. No, I'm not rounding to the answer. They want us to round our answer to the nearest tenth. Yeah, so I just rounded it to nearest hundredth. I have 234.08. Well, I'm not going to keep all those decimal points. I meant I'm not rounding to the nearest tenth until the very end. Okay, Mary, what's R? Good, 15.3 inches. So there's part of our answer. How do we find diameter, Sean? Good, so diameter is equal to 30.6 inches. Questions? Jeremy, question? Because it's just a formula. You'll do a proof of that in one of your math classes eventually. We're not proving formulas in pre-algebra, we're just using them. Okay? There is a reason though. Yeah, just not time. We only have a minute left. Annalise? That, yeah. Yeah, but we're not getting to that until volume. Right. Not in this lesson. It's going to happen when we get to surface area and volume. Okay, so I need you guys to put a circle around letter A on the closure. That's part of your homework. Okay, so letter A on the closure. You're going to do that. Oh, and you're going to do practice 10.4. We're going to talk about it in a second here. Numbers 1 to 21, which is all of them. So I'll say that again. You're going to do the closure, letter A in your notes, and practice 10.4, numbers 1 to 21. Looking at letter A real quick on the closure, anyone have any idea how to start it? I want you guys to think, of course. Doug, how would you start it? Well, don't tell me. Okay, go ahead. You can keep doing that. Go ahead. Okay, so but the bigger picture, how would you do it? You have to find the area of the shaded region. Emma H? Yep. So find the area of the circle, area of the square, subtract them. Okay? That's all I'm going to say. I want you to try it. If you feel like you need more practice, go ahead and try B as well. But I just want to see A on Monday, as well as practice 10.4, 1 to 21. I'll check both of those. I have a review we're going to work on in class. Quiz definitely Tuesday. Questions? Sean? Doug just went over that. 8 is the diameter. Okay? That's all I'm going to say. I want you guys to figure out the rest.